Okay, expanding binomials. These can be a little tricky. So pay close attention, and hopefully I'll explain it in a way that it's easy to do. Okay, so it says use Pascal's triangle to expand x minus 2 to the 5th power. If I really wanted to, I could just do x minus 2 times x minus 2 times x minus 2 5 times. But that's not what they're asking me, so that's what we'll do. We'll use Pascal's triangle. Okay, so let's talk about where the 5th row is. First of all, we have our 0th row. Then we have our 1st row, 2nd row, 3rd row, 4th row, and then finally we have our 5th row. That looks like a 51. It shouldn't be, it should be more like over here. Okay, so I am going to use these coefficients when I'm expanding this binomial. Okay, now when you're expanding a binomial, there are 3 parts in every term. All right, there's this part we have to think about, okay, and then there's this part, the -2 part of the equation, or of the expression, okay? So, looking at Pascal's triangle, I know that there's going to be 6 terms. I forgot to set my timer again, because that's what I do. All right, there are 6 terms. So what I'm going to do is I'm going to kind of give myself my 6 terms here. And there are 3 different things. There's your x part, there's the -2 part, and then there is your Pascal's, I'll say PT, the Pascal's triangle part. All right, this first term is x to the 5th, right? That makes sense. When we are multiplying all these in a row, the first one is going to be whatever it is to the 5th power. So that's x to the 5th. And then they're going to go down from there. So we've got x to the 4th, x to the 3rd, x squared, x to the 1st. We don't put a 1 there. And then there's nothing, because honestly, that's like saying x to the 0th. And x to the 0 power is 1. So nothing goes there, an imaginary 1. The second part of this binomial does the same thing, but it goes the other direction. Okay, and you can write it backwards, or you can think about it just the exponent is going backwards from here. So right here I would have -2 to the 0th power, so nothing goes there. Here I would have -2 to the 1st power. You know, I'm going to put a 1 there. Then I have -2 to the 2nd power, -2 to the 3rd power, -2 to the 4th power, and -2 to the 5th power. Now one thing I want you to notice is that the exponents will always add up to the exponent here. Okay, so here's 5, here's 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, and 0 plus 5. Finally, we're going to throw in Pascal, good old Pascal, 1, 5, 10, 10, 5, 1. And Mrs. Oldham, what in the world are you doing? That does not look like a polynomial. Well, now I'm going to multiply these together to get, well, I should do it this way. I'm going to multiply it to get my terms. So this one is x to the 5th. This one is going to be 5 times -2 times x to the 4th power. So this is plus, I'm going to put a minus. Minus 10x to the 4th. Okay, this is going to be a plus. So 2 times 2 is 4. Times 10 is 40, x cubed. This is going to be a minus. So -2 to the 3rd power is -8. Times 10 is -80, so it's -80 x squared. This will be a plus. 2 to the 4th power is 16. Times 5 is 80? What is it? It is 80. Yep. 80x. Then negative 2 to the 5th power is negative 32. So x minus 2 to the 5th power is this polynomial right here. I hope that made sense, because now you know what I'm going to say. I want you to try one. I picked one for you that is a little bit smaller. Okay, so while I'm erasing, go ahead and pause it, and we'll do this in just a few minutes. Okay, so did you really pause? Did you? I hope so. I hope you tried this. I hope you gave it a good try. So let's use Pascal. So let's do this again. I know I just erased it, but here's our 0th row, 1st row, 2nd row, 3rd row, and our 4th row. So my 4th row has 5 terms. So 1, 2, 3, 4, 5. And I've got my x value, I've got my 3 to worry about, and I have my Pascal triangle coefficients. All right, so if this were 2x, then it would be 2x to the 4th power, 2x to the 3rd power, 2x squared. That's how it would work, but I'm just picking an easy one right now. So this is x to the 4th, x to the 3rd, x squared, x, and then x to the 0, which is 1. Okay, 3 to the 0 is 1. We've got 3 to the 1st power, 3 to the 2nd power, 3 to the 3rd power, 3 to the 4th power. Okay, and look again, my exponents are all adding up to 4, which is what I need. Okay, and now throwing in Pascal, 1, 4, 6, 4, 1. Okay, so 1 times x to the 4th is x to the 4th, plus 4 times 3 is 12, x to the 3rd. 6 times 9 is 54, x squared. 4 times, well, 3 cubed is 27, times 4 is 108, x plus 81. Okay, so that is your x plus 3 to the 4th power. All right, lastly, we have your homework. And again, like I said before, this is on big ideas. I don't think I really need to tell you guys that anymore. You've done this before. But in case you can't get onto big ideas, here's the assignment. Here's my picture of football players shaking each other's hands, just like multiplying polynomials. I bet the next time you see a coin toss, you'll think of multiplying polynomials, right? Okay, well, if you've got questions, make sure you ask me. Thank you.